Okay, so let's start our lecture today. So uh, so last time we want to find some cancellation. So we want to find some cancellation of let's see. So here first we sum over let's see. So over 1 positive 1 sum, and then so this is the sum of m from 2 to infinity a squared minus m squared b squared over a squared minus m squared b squared plus 4m squared a squared b squared yes, and then we have other sum from so this is the sum over like all the like so here the analysis, and then I'm picking out the diagonal analysis. So basically, for example, these are the evenly like the unit analysis of length 1, 1. So I1, and then I do like a diagonal, and then so what I do is that I'm looking at so this is like at level 1, right? And then I go left like that, and then I start at level like the vertical level 1, and then I go up. So this is like I start with so sorry, this is yeah, so this is like the vertical level 1, and then you go sorry, horizontal level 1, and then you go right, and then n from 2 to infinity of so here you have n squared a squared minus b squared over a squared minus m squared b squared plus 4, sorry, this is wrong. So this is so n squared this is n squared a squared minus b squared plus 4 times n squared a squared b squared. Okay, and then what we have is that we have so we are looking for some cancellation, right? So I think the cancellation basically it varies between the numerator and the denominator, right? So for the denominator, okay. I think the denominator, the scenario is a little bit different, because if I look at the denominator here, right? So let me do some analyzation. So some analyzation. So so actually the denominator of so that's interesting. So of the second sum, so let's call this 1 and let's call this 2. So the denominator of 2 is exactly so I can pull out like an n squared. Oh, sorry, I can pull out like an n squared, a squared, and then times yes, so times 1 plus 4a squared b squared, and then plus minus b squared. Yeah. So namely, it grows like 1 over n squared, right? And yeah, so this is the dominating factor. And then but the denominator of one is so basically I pull out like a m squared b squared, right? Then times 4b squared. Okay. So sorry, 4a squared. M squared b squared for a squared minus. So it should be minus 1, right? And then plus a squared. Yes. So yeah, right. So what is this AB, by the way? I forgot what is this AB. So yeah, so these ABs, they are exactly the modulus of the omega 1 and the modulus of omega 2, right? So yeah, so I feel like in this case, yeah, so let's consider the case where the 4a squared is positive, in the sense that this thing is also positive, right? So otherwise, I think So because if it is not positive, I think we can like increase the so here is m side 2, right? So here we start at n equal to 1, right? So basically, if I'm not starting at n equal to 1, then I'm starting at n equal to 2. So this becomes what? This becomes 4a squared. So let me think. So here, so this should be n, right? So when I pull out this, So this term actually, so because here there was a 4m squared, n squared, a squared, b squared, right? So if in general, so there should be like an n here. So and then if there's an n here, then for this n large, this term is always positive. So therefore, because here I'm letting n equal to 1, right? So here this is n equal to 1. So originally there should be like an m squared, n squared or something, and then I'm letting n equal to 1. So therefore, this becomes 4m squared. So yeah, so this is originally there's like an n squared. Yeah. And so therefore therefore yeah, so therefore I think it's reasonable to assume that this 4a squared minus 1 is positive. Yeah. So yeah, let me, and then yeah, so suppose that this is positive, so we can assume a result of loss homogeneity that we have 4a squared minus 1 is positive. Um, yeah, yeah. So strictly speaking, I cannot do that. So yeah, strictly speaking, I think I cannot do that. So let me think. So what should I do? So what should I do here? What should I do here? What should I do here? Let me think. For a squared minus 1 is positive. Oh, okay. Yeah, so let's just assume that. Okay, let's just assume that. So, let's say, yeah, so let's, because, yeah, let's just assume this one. Yeah, so for a square, it's positive. Okay. And then, so yeah, so this is like the denominator, right? So, let me think. So roughly speaking, yeah, so let me think. So this is like m squared, right? Multiplied by b squared times this number. Here is n squared times a squared times this number. Wait, I think I made another mistake here. So this should be just the 4 b squared, right? Okay, so I think roughly speaking, these two terms, they're like the same. And then, right? So so like, yeah. So like these terms, so these two terms are the same, and then I'm having that. So this is one and this is negative one. So there might be some trouble. Yeah, so there might be some trouble with the plus or minus 1. Okay. So, and then for what? So then, oh, so, wait, what do I want? So, yeah, so then, yeah, So I think that's all I can say about the denominator right now. So let's analyze the numerator. So analyze of the numerator. The numerator. So for the numerator, I think yeah. So for the numerator, I think that so here there's like a square minus m squared b squared, n squared a squared minus b squared. So so what can I get? So so they are like the same, but but differs like some a squared b squared, right? Differ from the a squared b squared. So can I say that their difference is very small? Can I conclude that? I think so. Right. So let me just try this. So so analyze the numerator. So yes. So let me see this one. So let me change this one to the n squared. So here I said 4 n squared a squared b squared plus n squared a squared minus b squared. So and then so this one is equal to let me do it in this way. So 4m squared a squared b squared minus m squared b squared plus a squared. Yeah, so it may not be okay. So let me see this. So so analyze the numerator. So yeah, so how can I analyze the difference between these two, right? So let's pick one and do some calculation here, right? So let me just do that. So let's pick one. So let's say fix like n equal to m. Okay. So let me use m. Which letter do I want to use? So maybe I want to use n. Okay, so let me just use n. So let's say fix m to the n, and then so what I get is that I'm getting so let's add them up together. So so when m equal to n, I have so I have so let's say 1 plus 2. So let me just sum over these two terms. Yeah, here so here I was using 1 as like what like to denote like the summand here. So here for this one let me just say that it is the specific someone where the m is equal to n, and then number 2 is just fix any n, like arbitrary n. So this is equal to, so I take the sum of these two, so what I get is that so maybe I should say like fix any n, okay, and then I fix m to be equal to n. Yeah, so then what I have is that I will have these two to be equal to a squared minus n squared. Sorry, so this is n squared, and then b squared over okay. So let me use this as the denominator. So 4n squared a squared b squared minus n squared b squared plus a squared plus this guy 4n squared a squared b squared plus n squared a squared minus b squared over, so the denominator would be, sorry, the numerator would be n squared a squared minus b squared. So now I do the so now I multiply the common denominator. So 4n squared a squared b squared minus n squared b squared plus a squared times, so this is equal to 4n squared a squared b squared plus n squared a squared minus b squared. And then for this guy, what I have is that I'm having n squared minus n, sorry, a squared minus n squared b squared times 4n squared a squared, sorry, a squared b squared plus n squared a squared minus b squared plus n squared a squared minus b squared, and then times 4n squared a squared b squared minus n squared b squared plus a squared. So what I have is that let me just keep the denominator for a while. Okay, so I want to keep the, I don't want to expand it right now. So yeah, so let me just keep this as a bracket here, and then for the numerator, let me expand the numerator here. So so here I get, so here I have to multiply a squared to each of the terms, right? So I get 4n squared a to the fourth power b squared plus n squared a to the fourth power and minus a squared b squared and then I'm multiplying the negative n squared b squared to each of these terms. So it will be, yeah, it's a little bit. So negative 4 n to the fourth power a squared b to the fourth power negative 4 must become negative and then a squared is here, b squared n squared. Okay. And then you have minus n to the fourth power a squared b squared, right? So minus n to the fourth power a squared b squared. So minus, yes, n to the fourth power a to the fourth power a squared b squared, yes. And then minus, plus n squared b to the fourth power, right? Sorry, what is that? N squared, yes. N squared b to the fourth power. So last time plus, yeah, plus n, yes. And then, so for this one, oh, I think I'm running out of space. So let me just do it here. So first I'm having n squared a squared being multiplied to this whole thing, right? So so this is plus. Yeah, so let me just finish use this space here. So n squared a squared. So n squared a squared for n to the fourth power a to the fourth power. For n to the fourth power a to the fourth power times b squared. And then minus, so n to the fourth power a squared b squared. N to the fourth power a squared b squared. And then n to the fourth power, yes. And then plus n squared a to the fourth power. And then yeah, so and then minus, right? So so here so here I should use minus. So this is equal to 4n squared a squared b to the fourth power. And then it should be a plus n squared b to the fourth power. And then yes, plus n squared b to the fourth, yes. And wait, okay, and then minus a squared b squared. Okay. Is there any cancellation? I think I should expect the cancellation happens on happens on these two terms, right? So n squared b squared. So what is n squared b squared? So here this term. And also I should have this term, right? Wait. Oh, okay. I should not expect them to cancel, but I should really expect them to be very same, right? So they are not really canceling out, but yeah, they have some difference. Yes. So yes, so they have some difference in this case. So I know that the wait a second. Um, so they have some difference here. So what do I know? Wait, so okay. So I know that yeah, because the a square, b square, they are basically like very different, right? Yes, and then so that I should not really expect them to be cancelled out or completely. They're yeah. I think I should really expect them to cancel like out the. So maybe there could be some partial cancellation, but the question is that will this partial cancellation really works? I think that's the problem here, right? Um, or maybe I think I should care more about the n to the fourth power. Oh, okay. Okay, sorry. It's a very a little bit embarrassing. So I think I miscopied something. So yes, so there should be a square here. Yeah, I wonder why. Because without a square, I shouldn't really consider this question, right? So, but does this gives us something? If we have a square. So if there is a square, then but it's not if, but it's so yeah. So let me see. Yeah. Yeah. So so here on the denominator, what I should get is that so I first expand the sum. Minus n squared a squared b squared plus b to the fourth power plus 4n squared a squared. Oh, so actually I think it becomes n squared a squared plus b squared. Wait, let me double check. Yes. So yeah. So let me just uh, so let me just n squared a squared plus b squared. So squared. And then, so this should be the same, right? Because it will be minus 2m squared a squared b squared, right? Yeah. So we expand this term, right? It will be m squared a squared b squared minus 2m squared a squared b squared, right? And then yeah, so it also becomes plus. Oh, so wait. So and then yeah, so let me just add n here, right? So let me just add n here. So I'm thinking of if you switch the position of n and m, right? Would there be some cancellation? denominator is different. I think that's the story. Yeah. So namely, yeah, let me switch it back. So if you have, let me think. So what do we have? So namely, if I have a point n comma n, right? So I will get n square a square minus m square b square. Wait, let me finish it. So the denominator it should be n square a square plus m square b square. And then when I have m comma n, I get m square a square minus m square b square. Oh, so yeah, it doesn't work. I see. Yeah, I think in order for it to work, yeah, there must be some relation. Yeah, so there must be either some like. So for this to work, right? Yeah, so either I have to consider like the relation between A and B, right? So so what exactly do I want? Yeah, so let me see the time today. Okay, so yeah, I think yeah, so let me just see whether this argument will still work in this about the cancellation idea. So yeah, so let me just do this one. So so here let me just multiply everything to make them the same denominator. So here I would have the denominator as n squared plus m squared b squared squared, and then for the numerator, right. So when I fix m equal to n, right. So the first should be like n squared, right. then for the denominator, so what I should get, so I multiply the whole thing by n squared a squared plus b squared squared, so a squared minus n squared b squared times n squared a squared plus b squared squared plus n squared a squared minus b squared times a squared plus n squared. Sorry, it should be n squared. And then a squared and a squared plus n squared b squared squared so I think the denominator is like the same. So for the numerator, so what I have is that I'm having a squared minus n squared b squared times n to the first power a to the first power plus 2 n squared a squared b squared plus b to the first power, and then so plus n squared a squared minus b squared times a to the fourth power plus 2n squared a squared b squared plus n to the fourth power b to the fourth power. So So I think this is so let me just remove this one, maybe put it here. And let's see, so first I get n to the fourth power a to the sixth power plus 2n squared a to the fourth power b squared plus a squared b to the fourth power minus n to the sixth power a to the fourth power b squared minus 2n to the fourth power a squared b to the fourth power minus n squared b to the sixth power so oh yeah, so this is finished. 1, 2, 3. Yes, and then so this is a plus. Yeah, so maybe I should move it to another place. N squared a to the sixth power plus 2n to the fourth power a to the fourth power b squared and then plus n to the sixth power a squared b to the fourth power and then minus a to the fourth power b squared and then minus so 2n squared a squared b to the fourth power minus n to the fourth power b to the sixth power. Okay, so so let's focus on this term, right? So yeah, so since I want to analyze is there any cancellation that's happening in the summation process, right? So yeah, so you sum over the m's and then sum over the n's. M is negative. Okay. sum over the m's and then sum over the n's. Yeah, so how many cancellation? So let me see what is the time now. Okay, so let me just stop it right now, and then let me just continue next time.